Okay, so yeah, so this is what we were discussing yesterday. We're trying to understand the CI/CD and its tool chain. So right now, this diagram, what you're seeing right now, is about the tool chain, the tools which is required for us to implement our CI/CD pipeline. And few of these tools we have learned. Few of these tools are something which we have to learn, must have skill set which you need to have. And we will try to learn few of them, not all of them, or at least few of them. So for example, we have done Sonar, Snike, Trivi. We have not done the, I think Sonar, we have kind of seen how it gets implemented into a CI/CD pipeline. But Snike and Trivi, something which we have only tried with the command line. We haven't actually done it from the CI/CD perspective, but we actually know at least how they work and what is the use case where we have to, which it solves basically. Today we are going to be focused on this part, which is the Kubernetes part, because you guys need to understand how Kubernetes operates and how you can spin up a Kubernetes cluster and how you can deploy the applications there via CI/CD pipeline. But today we will not focus too much on CI/CD. We'll try to see how it can be done from your local machine manually. Because before you can implement something in CI/CD, you need to make sure that you can do it manually as well on a local machine. And once you know how to handle that thing, then you can actually go ahead and implement the same thing into a CI/CD pipeline. So for today, we are going to touch base on basics. So the first hour we are having today is about basics. I know there are a lot of people who have difficulty in understanding all these things which we are learning from the day one, which is how to create surveys, how to create, how to Dockerize it, how to deploy this into some cluster, let's say minikube, and then how to Helmify it. Helmify means how you can create Helm chart to deploy it, or Kubernetes manifest files. So all these things we have seen in the past. It just probably few of you may not have fully understood it, and we can try again from the very basic one, and from there we try to go towards the bit advanced stuff. So we'll try to implement or deploy the application into our Kubernetes cluster also. And that is what is my agenda for today. So let's start. You can stop me in between. Let's say आपको नहीं समझ में आ रहा है तो आप बोलो नहीं समझ में आ रहा है, and you can stop it and then I can restart it. So our 1 hour, 1.5 hour, 2 hour, whatever time we have, I'm going to start from the very basic. It will appear that I'm doing it from the day one, where ground zero. And from there, I will try to, one step after another step, I'll try to implement things, and we will eventually end up deploying our application into the Kubernetes cluster. So Kubernetes cluster के लिए Kubernetes को हमको spin up भी करना पड़ेगा. वो मैंने पहले से करा हुआ है with the same command which I demonstrated yesterday. Yesterday I demonstrated that command. Somehow it did not work. I don't know why. I ran it again today. It worked. So I'm not sure what went wrong, but I think for you, in your case also, it should also work. Okay, so I think let's start. Fine. So to start, let me create a new window. I will open a new window. Maybe that window you won't see here, so it's better I do it here itself. Okay, so I say, or I can simply go back and create a project here. Okay, so I am actually creating a small folder here. Let me give it a name. Let's say, what can I give it? Maybe static site, because a lot of static sites are there. So I'm just simply giving it the name as static site. Maybe with the date, let me say 8th Oct. Okay, let's say this is our folder. This is where I'm going to create my project. So I'm creating my project here, and I will go and open it. in my Visual Studio Code. So I will go ahead and let me share one more instance of Visual Studio Code. Let me open a new window and I will share that window as well, which is here, share. Okay, so I will go here and open that folder. So I'm going to go here and open static site 8 October 23. Okay, I'll open this folder like this. Okay, now here to demonstrate you, I will create a very simple website, a very simple application, a simple index.html. So I'll go here, index.html. I'll go and create. Now inside this, I will go ahead and write my HTML code. So I'll say HTML. Here I'll say my body. In the body, I will say maybe a header. I don't want this, so I'll remove this. I simply say hello world. I put my name here, Kashir. Fine. So I have application ready. Now you have seen how application look like. It doesn't look like this, of course, because this is a very simple index.html file. Application actually looks like what I have shown you in the case of, let's say, this one. So this is an application where you have an API, and applications, the real applications are much more complex than these. Even this one, this is also simple API. What I'm demonstrating right now is also something which is very, very simple index.html file. Now, once you have the application, and now understand, you don't go and create application as a DevOps engineer, release orchestration engineer, CI/CD pipeline engineer, whatever you wish to call it. You are not the one who go and write the applications, right? So don't get confused that you will have to go and create these APIs and all. No, you don't have to. It is not under your responsibility. A developer is the one who does that. He's hired to do that job. He goes and writes source code. He goes ahead and write the test code, the unit test code. And he also sometimes supposed to also write Docker file, because he's the one who knows how to build the application, what are the dependencies required to build an application. So he's the one in the real scenario, he's the one who does that. But for you to learn these concepts, because you don't have a developer, so you also need to know how developer is writing the code. It also gives you an exposure of what developer is doing and how developer does things. So it's good that you know some basics, but also in order for you to learn the concepts, you need to know few things. So to start with it, all you have to do right now is index.html file. This anyway can be considered as a simple web application, which can be served over an Nginx server. Okay, so when I tell you all these things, I see a lot of questions which based on a lot of questions I have heard. You guys are confused, who write this and who write that, who write the test code, who write the unit test. You are not the one who write that. That's the reason I'm repeating this again and again. Okay, right now to learn it, I have to write this. Otherwise, how will I go and Dockerize it? Because I don't have a ready-made application. Anyway, now I have just one file here called as index.html file. And now let's say my application is ready, but now I have to Dockerize it. Is the Dockerization only way to deploy this application? No, there are many ways. I don't need to necessarily Dockerize this. But since we are following the modern architecture, a containerized architecture, or let's say microservice architecture, there the best practice is that you Dockerize your application, so that whatever works on your machine will also work anywhere else. The biggest benefit of Docker or Dockerization is this, that you don't have to worry about the dependencies which you have on your machine, which is making the application running on your machine. You don't have to worry about that the other person who is running your application also have the same configuration. So you don't have to worry about that it works on my machine and doesn't work on other machines. And it happens a lot when you don't Dockerize it. So when you Dockerize it, what you're giving is application and all its dependencies and everything, so that if that Docker container is running on my machine, there's absolutely no way it will not run somewhere else. So this is the biggest advantage of Dockerization. Okay. So now I'll go ahead and write my Docker file. So to create a Docker container, you have to create a Docker file. Without Docker file, you cannot containerize it. Why? Because Docker file contains the instruction about how to Dockerize it. The how part is important here. If you don't mention the how part, then your application cannot be Dockerized, because you need to tell the Docker software what you want to do with your application, right? So Docker file is the file which contains the instructions about your application. Now this is a Docker file. Docker file, what is the content of Docker file? The Docker file mostly always starts with a keyword called as from, and the from, you need to mention the operating system and its dependencies. Now there are a lot of existing images already available for you to use. Okay, so when you say from, you can mention the name of any image, which actually in turn is a combination of an operating system plus any dependency you need to have on that operating system. Okay, in this case I am using a server called as Nginx server. Okay, so I'm going to use Nginx here, and I can use some version of it. Okay, so for example, you don't know what to use, right? And this is also some question which someone was asking yesterday: how will I know what to use? Google is your rescuer here. You go to Google and search for I want Nginx server, Nginx image, right? So you get to go here, you will see the link, and you go here and you will find a lot of images with the tags, and then how to use that is also you will get here, right? So when you go here, you go to tags, you will see a lot of images which you can use. Make sure that you're not using anything where you have vulnerabilities. Okay, so you can use a lot of these images to do things, and here you will see their tags. So this is the name of the image, and then what you see right now is the tag. So you can mention something like that. And when you say Nginx, it's not only Nginx. Nginx is a software, a server which is deployed on an operating system. So it could be an Alpine, it could be an Ubuntu, it could be anything, right? So whenever I talk about an image, the image also has two things. The image will always have one thing which is absolutely will be there, which is an operating system. It could be Alpine, Ubuntu, different versions, different distributions of Linux can be there, slim version, fat version, whatever, but it will be there. And on top of it, you will have the server, the software which is required. So in the case, yesterday's case, I think there was this Java application, right? Let me quickly open it. So I think you can't see this part. Let me open it. Let me share this screen again very quickly. Let me share this. Share. Okay. So for example, here, right? So if I go and open, okay, if we go ahead and see this Docker file. So here, if you see, I have a image which I'm using here, which is an Alpine latest, right? So when I'm using an image which is Alpine latest, only Alpine latest, that means only operating system is there. There's no other thing. So I wanted to make use of this image to run my Python application, because Python wasn't available here. I have to go and install Python on this machine, on this image. But there is also a possibility where I don't have to do it, because I will go and use an image which has Alpine operating system and it also has Python installed already. And if that is the case, then I will not have to go and install any Python there, right? So when you choose an image, you also always should choose an image which has all the dependencies for your application. Rather, you should not have to go and install these things. Okay, so same thing we will try to do here. I can also go here and say Alpine latest. I can also go here and say Alpine latest, but then I will have to go. I will have to then go and install the Nginx on this one. Otherwise, it won't work, right? But I don't want to do it, so I will always go and use a ready-made images which has OS and all the necessary software which I want on that machine for my application to run. Okay, so that's the logic of choosing the base image. Now, in my case, I will go ahead and use my Nginx. Uh, where is my Nginx page? Yeah, this one. So I'll go ahead and can use mainline Alpine 3.18 Slim. Okay, I go and when you so in a real world scenario, these things right now you see no vulnerabilities. But if you make a habit of always using the same image which you've been using 1 year back, you shouldn't do that. That's not a good practice because these images may have vulnerabilities. Right now there are no vulnerabilities, but maybe later some vulnerabilities are found. So you should not have a habit of using the same image every time. Okay, so right now if I am using this, maybe there are no vulnerabilities, but you can never be sure that no new vulnerabilities are found there. So always make sure that you keep on checking your Docker files. And anyway, that's a benefit of putting in compliance framework or the security scanning, container scanning, because container scanning that like Trivi can actually catch this. It can catch that, oh, this has vulnerabilities, and you will get to know that in your CI/CD pipeline itself before it gets deployed. Anyway, enough on this topic. I will go here and say Nginx. I want to use Nginx server. Okay, Nginx server, and here I will go ahead and then copy. So copy here means what I want to copy and where I want to copy it, right? So I want to copy index.html file from my system, from this folder, and I want to save it somewhere. That somewhere is user share nginx HTML. How would I know that? I knew it because I have seen this in the official documentation. Somewhere I would go, if I go here and go to the, let's say, official overview page. So here how to use this image. They're saying use nginx and then copy static HTML directory, whatever you want to copy, and then copy it here. So when you copy it here in nginx server, it will go ahead and serve that page. Server will serve that page on port 80. Okay, so that's what I am doing right now. If I go back again to my Docker file, I have copied it, and then I'm simply saying expose port 80. Now this is the simplest Docker file you will ever see. Okay, fine. Now next thing which I would do is I will go ahead, open the terminal, and now what I need to do is, so right now I'm doing everything locally. I'm not putting in any CI/CD pipeline. I don't want to confuse it. Let's just see how things can be done from a local machine. Because what you can do from local machine, the same thing you can do from the CI/CD pipeline. If GitLab, Jenkins, doesn't matter. Right now, for today, I will only focus on how you can do all these things from a local machine. From Docker file to Helmify it, to deploy it in minikube, and then deploy it into EKS cluster. So this is all the thing which you're going to see today. Now let's Dockerize it. To Dockerize it, you need to first make sure that your Docker instance is running, Docker daemon is running. I already have it running. Then I will run the Docker build. Docker build is the command which builds the Docker file based on whatever is written inside Docker file. So it has to have the Docker file. If Docker file has a different name, then you can pass the name using -f, like file name. Right now, the default file name is Docker file, and that's what I have here. So I say Docker build, and then what I do is I will have to put a tag here. So I'm saying docker.io.333.743. This is the name of my repository, right? So I have a Docker Hub repository which has this path. So I have to put that as in the beginning first, and then I will give it a name. So let's say I'm giving it a name as what name I should give here? A static site. Okay, let's give the same name so that we don't get any confusion. 8 October 23. Okay, and then I give it a name, give it a tag. So I'm giving a tag as latest. Okay, and then put a dot. Dot means the context here. So I want to have all the files to be scanned by Docker before it can do all these copy and paste operations. So our dot is important at the end, and I say enter, and it will start building it. So based on what it's doing, it will take that amount of time. This is the simplest file ever. So this is what it took, like 10 seconds, I think, and it has built this file. I can go ahead and try to run this. So always when you build the application, try to run it to see if it's working fine on your machine. Otherwise, what's the point if you build a faulty Docker image और वो नहीं चल रही है आपके सिस्टम पे, so what's the point? So you have to always make sure that you always run it. जो आप build कर रहे हो उसको run करना है आपको, ठीक है? So I will go ahead and run it. And what port I have to mention? I can mention any ports. I say P, and then I would say 8085. This is my local port. Should send the traffic from 8085 to port 80, because port 80 is what my container is listening on. So जो भी 8085 पे traffic आएगा, I would like to send that to port 80. Okay, and then I press on enter, and then my application should start running. And how would I go and check it? I will, very simple, I go to browser, and then I go to localhost 8085, and my application is running. Hello world Akash here. That's what my application was when I created it. Okay, let me do certain things very quickly. Okay, I want this window. I'm sorry, I have many windows opened and I'm getting hard time to switch to all of them. Okay, I think I am sorted now. Okay, so now my application is up and running. Okay, now what I do is I come back here and I'll stop it. I don't want this to run continuously on my local machine. Only thing which I wanted was to test it, and I am able to test it. The application is running on my machine. That means it will run anywhere. The next step which I will do is I will go ahead and push it. So I'll say docker push what was the name of my file? I'll go ahead and copy it, and I will say docker push, and I will go and push it. So when I say push it, I already have a Docker account. So there are some prerequisites here. Okay, you have to have a Docker Hub account where you want to push it. Okay, Docker Hub is not the only library, registry where you can push it. You can push your Docker images to any registry. AWS has its own registry, public Elastic Container Registry. Google also has it, GCR, Google Container Registry. So based on what path you have put here. So for example, if you want to push this into Google Container Registry, you will say gcr.io, not docker.io. If it's AWS, then it would be something like aws.ecr or something .io or something. So based on where you want to push it, you need to tag it in that manner. So right now, by default, I'm publishing it to Docker Hub. I have tagged it as docker.io 333743. And also I have to do a Docker login, right? So Docker login is also important. When you say Docker login, it asks for username and password. Username and password you will get once you go and have a Docker account. If you don't have it, then you can go and generate your password. So 333743 is my user ID, and I can go here in security and generate my token. So I can say new access token, generate a token, and use that token as a password. Okay, so Docker login is also important. Now let's just go and see what happened, because I just pushed it. मैंने अभी इसको push किया है, right? So अब मैं इसको देखूंगा कि ये यहाँ पर push हुआ कि नहीं, and it got pushed here. Static site 8 October 23. It wasn't there. It was just pushed 1 minute ago. And that is my latest image, and it's pushed. And now you can go and copy this. If I say public view, you can go and copy this command, and you can try to run on your machine, and it will run exactly the same way how it ran on my machine. That is the advantage I was talking about in the beginning, right? So this is the advantage of Docker कि मेरे machine पे चल रहा है तो आपके machine पे भी चलेगा, right? This is the advantage of Docker. So what I've done so far, I have created a Docker. I have created the application. I have created a Docker file. I have done a Docker push. and I've done a Docker Docker build and Docker push. Now what I do is I will try to write it so that diagram.draw.io, and I will quickly create small blocks that what I am doing. So I have created an application, rather I will use the text. So app created. Okay, then I have written a Docker file, right? Then I have done a Docker build. Then I have done a Docker push. So this much I have done. Docker push, image has been pushed to Docker Hub, image gone to Docker Hub, Docker Hub registry. Okay, as I said, it can go anywhere, wherever you want to push it. Right now I'm choosing Docker Hub to push my image. Okay, so what we are going to do next? Okay, now the next step which I can do here is I can deploy this application somewhere, because right now I'm just doing Docker run. Okay, I also did Docker run, by the way. So if I say Docker build, then I did a Docker run. Let me document that also for your benefit so that you can understand it better, that what are the steps which I'm taking. Okay, so I've done a Docker push, Docker run, Docker push, Docker Hub registry. Fine. Now what I do next is, right now I am running it on my local, but I want to run it somewhere. So right now I don't have any infrastructure where I can run it. So what I'll do is, the Docker container runs on a Docker platform. Okay, also called as an orchestrator. Orchestrator here means a place where these containers can run. I can run it on my local machine. Why? Because I have a Docker runtime, Docker Hub, Docker मैंने install किया है, Docker desktop. I have installed Docker desktop, and on Docker desktop मैं अपने किसी भी कंटेनर को अपनी लोकल मशीन पर रन कर सकता हूँ. But इससे कोई benefit है? Is there any benefit if I run my container on local machine? No, because only I can access it, and I want my application to be accessible to everyone. So I need to have this infrastructure available to the public so that people can access it. The best way to do that is that I deploy my application onto a Kubernetes cluster on a cloud platform, which is EKS, right? But I'm not going to go there directly. Let me show that how can I do that on my local, on an orchestrator, a local orchestrator, which is called as minikube. So before I can deploy any container onto an actual cluster, how about we test it on my local cluster? So Docker desktop के साथ में एक minikube नाम का container होता है. Minikube is a container which can be executed on Docker desktop, and you can run your application on Docker desktop. So what I do is I will say minikube start. When I say minikube start, it will go ahead and create this small, very minimum version of a Kubernetes cluster. उसमें सिंगल नोड Kubernetes क्लस्टर एक क्रिएट हो जाता है. वो अपने आप में खुद में ही एक कंटेनर है, पर इट एक्ट एज इफ इट इज ए Kubernetes क्लस्टर. सो आपका एक Kubernetes क्लस्टर अवेलेबल हो जाता है आपको लोकल पे टेस्ट करने के लिए. Okay, so what I would do now, so it's saying preparing Kubernetes version 1.24.3 on Docker. So it's trying to run the Kubernetes cluster on Docker. Okay, so let it spin, but before I can actually deploy anything on this, I need something, right? That something is called as manifest files. Manifest files Kubernetes का concept होता है, जहां पर Kubernetes में आपको क्या install करना है, उस information को आप store करते हो एक किसी file structure में. So you need to create something called as manifest files. I'll go and create a manifest folder. Manifests, and inside this manifest folder I will go and create a service.yaml, and I will create two files, service.yaml and deployment.yaml. Are these files necessary? No. मैं kubectl command को use करके I can use kubectl command to directly run my container on the cluster, but I'm not going to do that because that's not how things work in the real world scenario. So you always would need something called as manifest files. इन manifest files का content क्या होता है? Manifest files are the files which contains the instructions of how the application should be deployed on Kubernetes. इन files में instruction होता है कि मैं Kubernetes में मेरे container को कैसे कैसे चलाना है, उसका instructions होता है इन files के अंदर. There can be many different types of manifest files. Right now we are only focusing on two, deployment.yaml and service.yaml. What is deployment.yaml? What is service.yaml? This is something which we have discussed in the past. So maybe I will just quickly go to that our old Miro board to give you some perspective of what we learned there. Right, this is what we learned, right? So services, so this is your node, this is your cluster. Uske upar you have Kubernetes Docker runtime. Then you have pods. These pods are equivalent to deployment. So when you say deployment.yaml, deployment creates these pods and replica sets. So there's some few things involved inside, but when you think of pod, you can also think of deployment, because deployment creates pods. And then these pods are linked to the services. And services has IP. So services are the logical entity in Kubernetes, which exposes your application to the outside world. Right, so service 1, service 2 points to this pod, service 3 points to this pod, and service has an IP. And to expose a service, you can use multiple ways. So node port आप use कर सकते हो service को expose करने के लिए, load balancer use कर सकते हो, port forward use कर सकते हो, ingress use कर सकते हो. हमने port forward we have used it a lot, which is just used for debugging. Load balancer or node port and ingress. These are the things which are actually being used to expose the application outside. Okay, so service 1, you want by default they are not exposed. By default they are given a cluster IP. Cluster IP is a private IP available only to the local cluster. But if an external entity wants to access it, then you cannot. So you need to assign service. You have to assign the service type as either node port or load balancer or ingress for this to be accessible to the outside world. Port forward is used for only debugging purposes. Okay, this is what we understood last time when we are learning this. So I'm just giving you a recap of how we learned this. What are the things which we learned while we were exploring this fundamentals earlier. You can stop me in between, guys. If you think something needs clarification, you can stop me and ask again. Okay, so don't shy away from doing that. Anyway, so I'll go back again here. My Kubernetes cluster is up and running right now. Okay, now what I do next is I will have to go here and write my deployment.yaml and service.yaml file. To do that, I will write my API version. So there's a specific structure of this YAML file. Okay, I say API version, kind is deployment. Okay, then I say, oh, not this one. I have to say metadata. Now this is giving me, by the way, whatever you are seeing right now is generated by GitHub Autopilot. I have taken the subscription for it, so it can generate it's a kind of AI which generates the code while you type, but it comes at a price. So I'm not saying you guys should go and buy it. I would say don't buy it, because if you want to learn, don't be lazy. I want to do fast things and I want to get quick suggestions. That's the reason I have installed it, but you don't have to, and you shouldn't. Anyway, these kind of files are not written by hand. You shouldn't be writing these manifest files anyway, because you mostly use Helm, and Helm automatically generate these files for you, so you don't have to do it. But you should know the default structure of how these things work and what are the content of these files. That's the reason I'm showing you how to write this. So you write metadata, you write name and labels, and the name you can put some name like I will give it a name as what name can I give? Let's say my static site. Namespace I don't need at the moment. Label I also say my static site. I also say 8 October, so that you know what we are talking about. 8 October, okay, 23. So okay, so I go here, and the label in the app also I will give it the same label, and then I will use the spec. And here also I will have to go and start writing my replica set. So I have to say how many replicas I want, then some selectors here. So I'm getting this regenerated thing, but you don't have to worry about. You can go and type it out. And if you ask me, frankly, don't type it out, because you will end up making mistakes and get stuck with it. That's what you guys do a lot. I don't want you guys to do that. So it's better you go to the official Kubernetes documentation. There are all these files already there, so you don't have to go and start writing each and every keywords and words here. Okay, so that's what I will go ahead and go, and I think to save time, let me just quickly copy and paste, because we have a lot of topics to cover. So we have API version, apps v1, deployment, then the metadata. Let me give some name, or let's just say my app. Let's give it a my app name. Let's not complicate things. My app replica set. I want one label as my app, labels as my app, and here I can give some name here. So my application name is 8 October. So I'm saying 8 October 2023. And this is the image which I created. That's what I'm giving here, or maybe I can just copy it and paste it here. So my deployment file is done, and I'll go and copy my service file also. Service file look like this. Service name selector is how it would know which application to point to, right? So whenever you're confused about services and pods, always look at this diagram. So pod is this, and to match which service should point to which pod, this selector thing comes into picture. Okay, so selector my app, it will go and find which deployment has my app, and it will connect it with that. This Kubernetes has this default behavior underlying, where it finds out which traffic from which service should go to which pods, right? So this is a minimum which I have to do, service and deployment. And here in the deployment, as is quite clear, the most important part is spec. And in this spec, in under containers, you have to mention the image name. तो यहाँ पर जो आपको इमेज रन करनी है वो पार्ट आप इस कंटेनर के अंदर लिखोगे इन डिप्लॉयमेंट. फाइन. एंड सर्विस के अंदर इतना ही लिखोगे केवल कि मेरा जो ट्रैफिक है वो किस पॉड के पास जाना चाहिए और किस पोर्ट पे जाना चाहिए. एंड इस डिप्लॉयमेंट फाइल में इंपॉर्टेंट थिंग है कंटेनर की इंफॉर्मेशन. कौन सा कंटेनर उस पॉड में रन होना चाहिए, विच कंटेनर यू वांट टू रन ऑन दैट पॉड इज व्हाट यू हैव टू मेंशन हियर अंडर इमेजेस, एंड ऑफ कोर्स कंटेनर पोर्ट. So it's not very different than what you were doing earlier. You were saying docker run, right? You were saying docker run, then you're saying port 80 whatever and 80, and then you are mentioning the whole thing, right? Oops, sorry. And then you are mentioning the whole this path. So when you were running on local machine, this is what you were running on a local machine. But you want to run in Kubernetes, you will go and mention the things on the deployment.yaml or service.yaml, which is also called as manifest files. Okay, good. Now let me close these files. Now what I do is I already have a minikube server up and running, right? So what I would do next is I will deploy this application on my minikube cluster, and we would see that how it's working there. So if I say something on kubectl. Now kubectl is a command line interface to interact with the Kubernetes cluster. kubectl को काम करने के लिए उसको एक बहुत इंपॉर्टेंट फाइल की जरूरत होती है, जिसे कहते हैं kubeconfig फाइल. kubeconfig file has the information about which cluster to point to. Now whenever I am running things on my local, when I am developing things on my local, I can have many cluster. I can have a minikube cluster, I can have cluster on AWS, I can have another cluster on GCR, I can have another cluster on Azure EKS, I can have many numbers of cluster, right? अब मुझे एक cluster पे अभी काम करना है, then I have to work on next cluster, then I have to work on next cluster. So how would I switch the context? This is called as context, right? This information is available inside this kubeconfig file. जब आप kubectl install करोगे, so there will be a file called as .cube file. Sorry, a cube folder नाम का folder होगा ऐसा. And inside this you will have a config file. Inside this config file, you have a lot of information. This includes certificates and namespaces and कितने cluster हैं, cluster के अंदर उनके certificates क्या हैं, or all these things will be there. But you do not directly access this. You don't have to go and do anything here. You can directly manage it from here. So आप लिखोगे kubectl and you say config and you say get contexts. And when you do that, you will see all these contexts available. Right now, the star means I am on this context. So I am available on this context. This is what it says. Okay. So what I would do next is I will, if I, let's say I'm not in that context, then I can go ahead and say okay, by the way, I'm not writing kubectl, I'm writing k because I have set an alias for my for kubectl so that I don't have to type all things. I'm saying k and I say config and I say current context. So it's saying my current context is minikube. Okay, that means whatever I will run now using kubectl command will always go and apply those things into the minikube cluster. So what I will do a cd to manifest and then I'll say kubectl apply -f deployment.yaml and I'll say k apply -f service.yaml. So मैंने apply deployment.yaml भी implement कर दिया, service.yaml भी implement कर दिया, sorry apply कर दिया. If I go and say get pods, I have a pod up and running here. Okay, this was running earlier. Okay, I think I need to install, otherwise you will get confused. K, okay, not K. Let me uninstall this. K. What I'm doing. Helm install my app. Okay, now I say k get pods. So now I have one pod up and running which I have executed. I say which I have applied. I say k get service. I have one service running. I say k get deploy. I have one deployment up and running here. Okay, so this is how you do. Now I go back here. What I've done here, after this, I have created manifest files. Okay, I have opened minikube. Then I have, after minikube, I have installed kubectl and set the context to minikube. This is what we have seen. I haven't done it right now, but I have already pre-configured it. But what I'm writing is that you have to do that. After that, I have done kubectl apply, right? So I've done kubectl apply, and then I can see my app up and running. How can I see my app and running? The simplest way to do that is port forward. So I can say k port forward pod. I can do service, I can do pods. I'm simply saying port forward pod and pod name. So I will copy the pod name and I say 80, 85 or 80, 86. So local port and where I want to target. So port 80. So I say 86. I go back to my browser and if it's not working, but if I go ahead and say port 86, it will work. So now the traffic from here is going directly to the traffic inside of this pod. I can go and run some more kubectl commands. So let me just quickly revise some of the commands which we have seen earlier, right? So let's say I do k describe. Describe is a good command to know what's happening inside. So to know what is the definition of the pod. So I say k describe pod. It will show me what this pod is made of and all these things. What were the events happened, successfully assigned, then pulling image, successfully created container, started container. If there is anything wrong, then you will see that event here. So if your container is not working, always try to see with the describe commands what can be wrong there. Okay, Then maybe you can see the logs, maybe so qk logs and name of the pod. Then whatever log which was there inside, which was generated by the application, you would see that log here. So few of these commands you can go and give it a try so that you know how to debug problems, because more often more often the application doesn't run and you will have to go and solve the problem why it's not running. To solve the problem, you need to know how to debug a container. So this is what you do. You try doing port forward, you try to describe the pod, you try to see the logs inside the pod, and these are the ways you go and debug it. Okay, so we did kubectl apply. Okay, then manifest files, kubectl apply, and then what did you do? After that, I did a kubectl port forward to see my application running up and running or not. So I did port forward, I did k describe pod, and I did k logs pod address. Okay, so I tried these many things. Okay, what next? So then now we are trying to go towards bit advanced things. So far it was just basics, very basic things. Some recap I did, some summary I provided. जो हमने पहले पास्ट में किया था उसी को हमने आगे बढ़ाया. तो अभी 1 hour which we have spent is just to understand the basics. Okay, so I think I should take a pause here. Any questions so far? Whatever we have been doing till now. Okay, so if no questions, let me continue. So next thing which we'll see is Helm. Now, why Helm is important? In a real application, there are not only these two files. There can be many files representing different applications, different configurations. Lot of things you may have to mention here, like service accounts, cluster binding, cluster role, secret, config maps, ingresses. There can be many such files there, and it's not advisable to handle all of them directly manipulating the manifest files, because you may end up making mistakes. So Helm is a concept which sort of automates your manifest files or YAML manifest files. So Helm में भी अंडरलाइन सेम ही कॉन्सेप्ट है, उसके अंदर भी डिप्लॉयमेंट फाइल्स ही मिलेंगी आपको, उसके अंदर सर्विसेज ही मिलेंगी, बट वो पैरामेट्राइज्ड फाइल्स होती हैं. दोज फाइल्स आर पैरामेट्राइज्ड फाइल्स, सो यू डू नॉट गो डायरेक्टली एंड मॉडिफाई दोज फाइल्स देयर, रादर you always handle a simple very plain vanilla YAML file called as values.yaml file. और उस values.yaml फाइल में जो आप मैनिपुलेशन करोगे वो ऑटोमेटिकली उन फाइल्स में जो एक्चुअल मैनिफेस्ट फाइल्स में अपडेट हो जाती हैं. सो लेट्स सी दैट पार्ट. आई हैव ऑलरेडी टेकन वन सेशन ऑन Helm. आई एम नॉट श्योर एनीवन हैज tried it because I have not seen any question related to Helm from you guys. So let's just see that again. Let's revise it. Let's try to understand it because it's a very important skill set you must have, you must know, and you must use. Okay, so now the next thing which we'll do is Helm. Now, how to start with it? To start with it, you need to install Helm, right? Because Helm is a software which you need on your local machine for it to work on your local machine. So you say Helm installing Helm. You would see instructions on how to install Helm, the different ways of doing it based on different operating system. So for Mac OS, I have just done this and it worked for me. For Windows, chocolatey, but I think don't do it. Otherwise, first you have to install this software, then it will work. I think the best way is if you have Ubuntu, then this should just work like that. But I think you can try this approach. Okay. So there are different ways to do that. This is not the only instruction set. I think you can just Google and you will get to know how to install Helm. So you need to have Helm installed on your machine. I will not go deeper into it because it's quite basic stuff. try installing it, doesn't work for me, then post in the group, we'll see what you're doing wrong, but it should be okay. Installation is not that big a pain, basically. So once you've installed Helm, then you can check whether Helm is working. So you say Helm version, and you should see something like that. Then to start with Helm, you go to your folder structure and you simply say Helm create chart. I'm sorry, I was inside the manifest. Let me go and do a cd, and then I will run the same command, Helm create chart. When I say Helm create chart, it creates a chart. Okay. Sorry. So in the chart, let's go through the files which we have here. We have a values.yaml file. This is the file I'm talking about, where you have to just modify few tags here. It's a very vanilla file. इसमें कोई आपको जो आप manifest files में उल्टी सीधी चीजें देख रहे थे, different replica selector, ये सब जो इतना जो tree structure आपको दिख रहा है, indentation दिख रहा है, that you will not see that in values. Values are just plain simple version of those manifest files. So you can mention few things directly from here. You can say image repository, and you can customize it. You can put your own keywords here, which you can put inside later. But right now it's image repository pull policy tag. So here you can mention what image you want to run, what replica count you want to run, secrets, service accounts, pod annotations, ingress settings, host, TLS settings, auto scaling, node selector. You can put anything here inside. It's a very, very simple file. So whatever I was writing earlier under manifest files, I would rather go ahead and do that here under the values file. So I'll go ahead and write things here. Okay, what is the tag I want to run? So tag you don't mention here. Tag is something which you mention here. Latest. I can say I want to run 2 replicas basically. Okay, and that's it. So instead of you writing this manifest files, you see how easy it has become. I don't have to write deployment file. I don't have to write service file. I don't have to write any file. I only have to say Helm create chart. It has created the chart, and the chart I have a values.yaml. In the value I have just mentioned replica count and image, and that's it. Right? So that's the beauty of why Helm is so popular when it comes to deployment of your payloads onto a Kubernetes cluster, because you don't really have to do anything. You just have to put the values directly in the values.yaml, and then Helm will take care of it. But let's just see how it is working, because internally Kubernetes doesn't really understand Helm. Kubernetes only understand manifest files. Correct? So what Helm has done it internally, that it also have the same file. So you see in the manifest files, हमारे पास deployment.yaml थी, service.yaml थी, right? It also has the same file, deployment.yaml, horizontal pod autoscaler, ingress.yaml, service.yaml, service account.yaml. It has all these things, but it has parameterized it, right? You see this double parenthesis and things here, values and automatic scaling enabled. And what it is doing is it is fetching these values from the actual values.yaml file. So for example, मैंने यहाँ पे लिखा है docker.io 33373 static site 8 October 23. To access this value, Helm will use image.repository. Where? Under deployment. So मैं deployment में जाता हूँ जहाँ पे spec है. ये spec है. Spec में container है. Container में image है. What is written? Values. It is saying copy the value from the values file, values.yaml file, then go to image, then inside it go to repository and put that value, and then put a double quote and then say value.image.tag. And if the tag is not there, then use a chart app version. So this is a syntax of how Helm manages, or how Helm parameterize its own files. Same here with the ports. The port name container port, value.service.port, right? So value here means value file, service is the tag, and port is the sub tag. So I go to values.yaml, and then Sorry, what was that? Values service dot port, right? So I go to values service dot port, service dot type. So all that values are actually being fetched from here, and then it is placed under that segment. So that value will be under service. So service values dot service dot port and values dot service dot type. This is coming from where? The values dot YAML file, which is coming from here. Okay. So summary. When I am using Helm, I don't use manifest files. So don't get confused that you have to create manifest file as well as chart. No, the chart is there so that you don't have to write your own manifest files. Simply imagine manifest folder is not there at all. You simply go here, Helm create chart, and then this is what you will get. You go to values.yaml and modify this values.yaml, and that's it. You don't have to go to templates and do anything there until unless it really required for you to do something there. Otherwise, you don't go and modify these values. You only do it if you want something and you are damn sure what you are doing. Only then you go here and modify things. Otherwise, don't touch it. It can break the whole Helm chart for you. It won't work. Once you start getting more, once you start familiarize more with how Helm is structured, then you can go and make value changes here. Otherwise, don't touch it. And it's not necessary to really go here to this level to begin with. Just focus on the values.yaml, because for you it's quite basic, simple cases. You don't have to go inside the templates and tinker with it. You don't do that. Just go to values, make changes, and it should start working for you. Okay. Any questions so far? Okay. The next thing which we will do is we will use Helm now to install it. So previously हमारे पास manifest files थी, उनको हम use कर रहे थे. हम कह रहे थे k and then we'll say apply and we'll say hyphen deployment file, right? This is what we were saying. Now we will not use Kubernetes to install the application onto minikube. So if I say k get pods, I have this pod up and running. Okay. But now I will have my chart up and running. So what I'll do is I'll say helm install my app chart. अब मैं इसका नाम दूसरा दे रहा हूँ. I'm saying helm install my app chart, and then I'm saying dot slash, and I'm giving the path. So basically I'm trying to say that please install my name of my application. मैंने अपना application नाम दिया my app chart, and then उस चार्ट का पाथ. तो चार्ट का पाथ क्या है? दिस इज द पाथ ऑफ माय चार्ट. सो आई एम डूइंग डॉट चार्ट. दिस इज व्हाट आई वांट टू इंस्टॉल. आई से एंटर and it will install, saying deployed revision 1. Okay, now if I go to say k get service, I have my app chart installed here. Okay, if I say k get pod, right now I have these 2 pods running because I have put the replica count as 2. So this proves that it has indeed installed the chart from here, and actually it has installed these files, not in the same format, because Helm converts these into the real Kubernetes manifest files, and that is what it implements or deploys. Okay, let's say I want to modify something. So I go here, go to chart.yaml. I want to say I am deploying a new version, so I change the version 0.1.1, and then I go to values and I want to say I want to only have 1 replica count. And then I will go here and I'll say helm upgrade. So previously I used helm install, right? I use helm install. So when you do it for the first time, you use install, but when you want to change the version, the new version of it, you say helm upgrade, then the name. So what name I gave? I gave my app chart, and then same thing. So now it is saying it has done the revision of 2. And now if I say k get pods, it has only 1 pod running. Okay, so this is basically how you use Helm to install your application onto a cluster. Okay, now let's go back to our diagram. What did we learn so far? So now we installed an Helm, and then we created Helm chart, and then we configured Helm chart in values.yaml, and then once we did that, we did what? Deployed or installed Helm on Kubernetes. Okay, this is also something which we did. So we installed Helm on the Kubernetes, not Kubernetes, let's say minikube, because we did not do it on actual cluster. And the same way we can access it using port forwards. Let's not do that because we know how to do it, but we have actually installed it there. The app is up and running there. What can we do next? Okay, so what can we do next is, my next approach will be, how can I make sure that this runs on any machine? So for example, if I want you to run this chart, I want you to do it, then how can I give it to you? So this is where comes the packaging of the Helm chart and distribution of the Helm chart. So now what I would do is, I will do a Helm package. I say the package name is, I can go into chart.yaml, and here I can give it a name. So I'm saying static site 8 oct 23. This is the name I have given, for example, and I will go to my command line and I will go and use this. I will use this file and I'll say Helm package name. Oh, sorry. I have to give the path. So I have given the path helm package.chart. The moment I do that, it created a zip file, tgz file it has created. And this is something which I can then push to a registry. So here again, the same concept of the registry comes, because I want to share it to the people. The same way I have published the image, the same way I can publish my Helm chart. And Docker Hub provides a way to publish the Helm chart as well. So to publish it, I'll say Helm. First of all, you have to say Helm login. When you say Helm login, it will ask for username and password. Put the username and password of your Docker Hub, the same username and password you give for Docker login, the same username and password you provide for Helm login. So once you do that, Helm will log in into that container registry, and then you can say Helm push the name, the file name, which is this one, right? So I'll say 0.1.1.pgz, and then I have to provide the path where I want to push it. So path of this is OCI and then registry 1.docker.io and 333.743. So this is the for Docker Hub. To publish a Helm package to a Docker Hub, this is the URL I have to provide. You may ask where I found this. I found this on a Docker Hub documentation. So OCI / OCI stands for Open Container Initiative, and this allows Helm charts to be published directly into the Docker Hub registry. I said 333.743 is my account name, registry -1 Docker.io. So if I said Helm push, it has pushed my Helm chart. I can show that here, this one. So if I go to the repository, and here, if you see, previously I have an image which I published latest, and in the same repository I have the Helm file also published. which is this one. And this is where it tells you how to use it. So you can say helm pull. So let's say you want to run it, right? You can just copy this, and that's it. And once you do that and run it on a machine, it will deploy on your Kubernetes cluster. So if your Kubernetes cluster is a minikube, it will deploy the application there. If your Kubernetes cluster is anywhere, it will deploy the application there. Okay. Any questions so far with the Helm?
Akash, I just have one question.
Yeah.
So basically, you were using minikube all this while. Instead of minikube, I was using micro-Ks. So will it all be the same?
Exactly the
It
same.
all works? Okay.
Yes, exactly the same. Because Kubernetes works the same way everywhere, right? If you minikube or you use micro-K8, doesn't matter. Kubectl will work exactly the same way. Helm will work exactly the same way. Okay. Okay, cool. So now what I do next is, what is the time? Okay, we still have a lot of time. So now let me make quick arrows so that we don't forget what direction we are going into. So here and then here. So install Helm on minikube, and then what we did, we also deployed Helm on. Basically, we pushed the Helm chart. Pushed Helm chart. Okay. Okay, we pushed Helm chart onto the Kubernetes cluster. Sorry, push Helm chart onto the Docker Hub. Helm chart to Docker Hub. Okay, what next? So अभी तो everything we were doing on our local, हम लोग local पे कर रहे थे, and this is what we were doing. Now let's see what we can do, how we can do all that to the actual Kubernetes cluster. Okay, so now comes the real deal. So Kubernetes cluster, we are going to use the AWS EKS cluster. Okay, now before I do that, I think I need a break. Let me take like 2-3 minutes break. I'll go and have some water and come back.